Yes.
Okay.
Uh,
So first of all, good afternoon, everyone. This is Sara Kale, the President of Data Science and Business Analytics Club. Good afternoon to our esteemed speaker, Ms. Ananta Sharma, ma'am. A very good afternoon to our dear Principal, Madam, Dr. Hemlata Bagla, ma'am, Vice Principals, Mojit Padi, sir, Dr. Shalini Sinha, ma'am, Justin, sir, Dr. Tejasri Shanbag, ma'am, and lastly, our dear Coordinator of Data Science and Business Analytics, Professor Shaileja Rane, ma'am. A very good afternoon to my teachers and my dear friends who are present here today. Welcome to the first ever program of Data Science and Business Analytics Club, that is the Maya workshop. I request every participant to keep their devices on mute throughout the workshop. If you have any questions during the workshop, please type them into the chat box and they will be later answered during the question and answer session with the help of the ma'am and Hardik. Friends, we have gathered today for the Maya workshop to listen to eminent scholar Ms. Ananta Sharma ma'am. She is a trainer with Creative Line Institute who train and hold workshop for students and companies in various softwares just like Maya. She has also specialized in 2D graphics, UX, UI design, and 3D softwares like Maya. So we can begin the session, ma'am.
Okay. Thank you for such a warm welcome. I guess we're back to online classes again. Did you have the offline lectures in between for a couple months?
Yeah, for the data science, we did have 1.5 months of offline lectures, but then again, the new virus.
Yeah, that's how it goes. Happy 2022. Okay, so let's begin. Right. So when you open your Maya softwares, this is the kind of workspace that you'll be dealing with. Now, I know it looks a little hefty and, a little complicated, but it's really not. It's really fun. So let's just go through the interface once. Just 1 second. So we'll just go through the interface once. See. Now, this is your status line. This is where you can find different stations for different departments of the post-production line. That would be modeling, rigging, animation, VFX, and the rendering. Then this shelf will allow you to access all the tools that you need quite easily for different, again, there are a lot of departments in this. You may not need all of them. So we'll just go through the basics and understand what helps us do what. So while, can I get this out? Just 1 second. Great. Okay. Right. So these are the shells. This is the toolkit that you will be requiring throughout. There is the range slider. This will show you exactly how many frames that we will be animating. So as many of you might know, there are we go by the 24 FPS rule, that is 24 frames per second. So to animate 1 second, you need to create 24 frames. So in the early days of animation, all of these frames used to be hand drawn. But now that we have these high-tech softwares, we don't need to do that anymore. So we can just have a lot of in-between frames that are created for us by the software computation. All right. So now this little thing is the outliner. This is going to show me all the props that I have in my sorry, this is going to show me all the props that I have in my scene at the moment. And this is the attribute editor section. These are the main things that you need to know about before we start working. And then we can begin. So now Maya basically works on two different things. One would be curves and the other would be polygons. Now there are curved based meshes and polygon based meshes. For curved based meshes, you have two main kinds of curves, that is EP curve and the CV curve. Now EP curve is what? It's based on edit points. I'll show you. This right here, this is the EP curve. So if I go to my side view, and again, you may want to write the shortcuts. So I can toggle between my viewports using the spacebar. This is my perspective viewport, and these three will be my orthographic viewports. Now again, I can change the order in which where I want the perspective and where I want an orthographic viewport. Orthographic viewport matlab, it will show you the two-dimensional view of your 3D object. जैसे कि सिर्फ top view देखना है या सिर्फ front view है, सिर्फ side view है. So all of those things are orthographic. In my perspective viewport, I can rotate the viewport and see wherever I want to see, like, you know, in different angles. So this will help me in terms of lighting and in terms of even modeling. So we'll come to that. Now, for now, the EP curve. I'm going to go into my side view with the shift spacebar. And see, I'm just clicking and moving on. And it's allowing me to create a shape. This kind of a curve. Now, in this, you will notice whenever I'm done, I press enter and the curve is ready. Here, you will notice that wherever I clicked, there was a point that got created. That is my edit point. For CV curves, that is slightly different. Let's see. So see, I've created this, but for CV curve to actually work, there have to be more than 3 points. But when my 3 point, the curve is actually over here. It's not on the points. So the curve does not actually follow the edit points. It follows the curve that the edit points form in between. So the only difference between these two is that the CV allows me to have more smoother curves and it's easier to manage. And EP is much like the Bezier tool or the pen tool that you have in Photoshop, if you have tried that. Okay, so now let's actually create something with this. So anything that you create with this EP curve or CV curve, all the curved surfaces, they're called NURBs. That is non-uniform rational Bezier splines. Now I know it's a big term, but you don't even have to remember it. It means nothing. It basically means that everything that you do will be based on a curve, on a spline, you can say. So I'm going to take a EP curve and let's create a wine glass. So again, I'm just clicking wherever I feel like to make the shape that I want. And I press enter. But before I move on, if I right click on this, you will see I have different components. So for a curve, for any NURB surface, these are the components that you will find. You can edit the edit points, the control vertices, curve points, and the hull. So all of these things are just to help you manage what part of the curve you want to make smoother. So for now, I'm just going to go to my edit point. I'm going to select this last edit point and press F. So F is basically for full screen. And again, you want to write the shortcuts because these are the shortcuts that we'll be using throughout. So I just selected this one point. I press W. W allows me to move. So this is the move tool. So you can see over here, there are certain tools that are given to us. This is the move tool. So what I want to do is basically, I want to keep this close to my point 0. So this last one needs to be at my point 0, because now what we're going to do is I go back to object mode and I select this whole curve and pressing spacebar again. I go to surfaces, revolve, and whichever axis I wanted to move to, I just go to that. For me, this is y-axis, and this will give me a chalice of sorts. So this is a very simple way of creating it. However, now here, you need to always make sure that this black side, this needs to be inwards and the white needs to be outwards. So that is how the reflectivity will also work after you do the lighting and the compositing of it all. So if we have such a situation, the only thing we need to do is we go back to curves and we go to reverse direction. And this is what we have. So now you will notice that this curve is still connected to this surface. Like if I move the curve that we had created, it is still affecting the surface. So which means they have a symbiotic relationship at the moment. So if I want the curve to be separate from the surface, I just go here, I go to edit, delete by type, and delete history. So now the shortcut of this is Alt Shift and D. So I'll just select this, Alt Shift D. And just like that, I can move my curve out, and this is a standalone object now. So this is an object in itself and will not be affected by the curve or the other way around. Okay, now let's try something with the CD curve. Again, going to my side view, spacebar. All right, so let's create a pot. So again, I'm just moving my mouse and I'm clicking. So something of a ceramic vase that we're creating. And I press enter to complete the curve, and right click, again, edit point, selecting the last one, pressing F. F is for full screen. Right, and here I can again tweak my curve as much as I want. Here I just want to show some thickness at the mouth of the pot. So I'm going to move this around a little bit. Now again, right click to object mode, selecting this, going to surfaces, again, pressing revolve. So you'll notice I'm not able to rotate the viewport here because the orthographic views, they're always locked. So I go to the perspective view, and here I can rotate it by pressing Alt and right click on the mouse. Alt, right click, and Alt, left click, and moving around. This will help me rotate the viewport. Now, again, I'm not moving the object here, but I'm just rotating the viewport. Now, to move the viewport, that would be Alt, middle mouse, and drag. And if I want to just dolly in and dolly out, zoom in, zoom out, that would be Alt, right click, and drag. Again, here when I do this, I'm not changing the scale of the object, I'm just moving around the viewport. So again, we're facing the same problem over here. So what we do is we just select the curve, we go to surfaces, we reverse the direction, and there we have it. Now say that I want to shift this, I want to shift the weight of this object. Like I want it to be bigger at the top. So we go to deform. We go to deform. There's something called non-linear. Now here we're going to try something known as flare. You select the curve first, then you go to deform, and we go to flare. Now let's see. Now here you have some options. That's about start flare and end flare. So basically what it is, your x-axis and z-axis. So your y-axis is in the height. So that will not be affected during the flare. What will be affected is everything you see in the top view. So say my x-axis in the beginning, I want it to be, say 5. I'll keep my start flare to 5 on both sides and my end flare to say 2. See, now again, this is happening because previously, as we saw, the curve had a different shape, but now these are interpenetrating each other, which is why we're getting this kind of an outlook. Okay, so let's see a few more nonlinear deformers. So these are known as nonlinear deformers because they can transform your object into anything that you'd like. But before that, let's look at some polygonal primitives. Now, we have already seen the basic, again, I will repeat those. The basic shortcuts that you need to know. First is F, that is full screen. Then is Q. Q is for selection. This is your selection tool. W tool. I can move it in any axis that I want. X, Y, Z. And E is for rotation. Again, we can rotate any prop that we have in either of the axis. And of course, Control Z is the same always. And finally, we have the scaling. So that is by R. So it's basically quer, the first 4 keys of your keyboard. So you have that. Again, we scale it in any direction. And if I want, say, to scale it in both these directions simultaneously with the same values, I have an option over here. Okay, now let's see what kind of polygons that we have. These are the polygonal primitives. Starting with the sphere. Now, this again, these are the basic shapes that you learn as a child when you're just starting out learning about art and drawing. So you have the circle, the square, the cylinders. So all of that, you just bring that into 3D. Now, the basic sphere will give you these options. It will allow you to have a number of subdivisions. Now, these subdivisions, these will tell you how smooth your object is going to look. Say if I want something like this, so it will give me by 6 to 4 subdivisions. So by changing the subdivisions, I can create different kinds of polygons. So if I want a sphere that is completely round, so then I can just keep it by 20 by 20. So this is the attribute that Maya gives you at the very beginning. Now this is the cube that we used previously as well. So again, now this allows you to have a separate height, width, and depth segment, and the separate subdivisions for each. Now this is extremely important in terms of blocking. So see, how the pipeline goes is, for anything to be created, like if we have any Marvel fans, so for the whole process to be done, first you shoot the live action, you do the pre-production, the stories and the plotting and everything, and then during the production part, we start with modeling the props. We have to model the different kinds of for the Iron Man suit, all of that CGI cannot be done during the live action, so you have to have the Iron Man suit as a prop as well. So the creation of that, all of that happens here in Maya. So you start with the modeling department, then your models go to the animation and the texturing departments simultaneously. So while the prop is being textured, you also start rigging it. By rigging it, basically, it means that you give it a structure, you like a set of bones. So if you move your hand, so for that to look realistic, there needs to be a certain set of joints that will, allow your arm to only move a certain way. Your wrist cannot go backwards 360 or something. So all of that, you need to create a joint setup, which is done during the rigging. So that's not just for characters, even for props, you can rig any prop to work according to what we want. And then after the rigging is done, we send it in for dynamics department. That is where the FX happens. Like the Doctor Strange, the thing he does with the hand to open a portal, that is part of FX. And finally, once we get the textures and the secondary animation is done, the textures are here, then we go to rendering departments. So now this is where the actual composition and the actual magic happens. So lighting is something that we'll be dealing with tomorrow. For now, let's come back to the basic primitives. Okay. Now this is, again, so these are the objects that are there on my shelf. However, if I go here and go to my polygonal primitives, we'll see that I have so many more. Each of them will have certain attributes that can be explored. For example, again, you see the number of subdivisions a cylinder can give you. If you just put it to 3, you can have this. You can have a prism-like shape. See, and I can right-click. I can select a vertex, say this one, pressing B for soft selection, B and drag. Now I'm drag, left-click dragging. So this will allow only certain vertices to be affected by the first one that I have selected. So if I move this up, else will also give me a smooth fall off. So see, all of these things I can create just by the basic primitives. Again, going back to object mode, we have a torus. Now this again is a very fun element over here, because this, you might think you don't use it a lot, but then it actually does work for FX. You need this for as a basic curve also. So you can reduce or increase the sectional radius of this and the height width divisions. Again, see. So this will again give you so many different shapes. And this. Now this is the most basic. It's the plane, but it's also the most important. So whenever you're working on any project, you start with a plane. So you have a base to come back to. Now you can use this this grid that we have as the base as well. However, if you use the plane, it will this grid won't be there when you render the object. The plane will be visible even after you render it. So this just gives you a little bit more professional look. Okay, now let's try to create something. Now again, I'm pressing R, giving it some height, bringing it above the grid. And again, let's try something of the nonlinear deformers. Let's create it first. See, I can start my angle at 0 and end it at 180, and it will give me this twisted shape. So it is still the same cube that I started with, and that cubic structure can be transformed into anything because we have these nonlinear deformers. Now you can try these nonlinear deformers later because there are a lot of possibilities with this, and well, I could show you them, but it's more fun if you try it on your own. Okay, so now let's create something. We will start again. Let's start with a cube. Now there are a lot of tools that you will find in the mesh, edit mesh and mesh tools, mesh display. All of these are used for polygonal editing. However, you may not, like as data science students, you may not need all of these in your projects, but we'll just use the ones that are, that are the most prominent. Okay, so we start with a cube, pressing R. Okay. So I've just flattened the same cube and I go to mesh tools to insert edge loops. Now, what are these edge loops? Edge loop is just an edge. I'm clicking on an existing edge, and around that edge, this will create another edge loop. So this loop runs around throughout the body of the mesh. So making the same edge loop on both sides. Now, when we press, this is the output when we're in mode 1. Now, on your keypad, when you press the number 3, you see something like this. Now, this is because of subdivisions. So when you press 1, you are at the normal mode. And when you press 3, this smoothens your model, which means it subdivides your model 2 times. So it will not ruin, but it will flatten the shape of your object if you don't have the correct block in. So right now I only have these loops that are the supporting loops. So I need a few more loops. So we're going to create a simple basic table right now. Okay, let's start again. Pressing R. Okay, shift to change the viewport, going in the side view, just seeing the height. Okay, now I'm going to go to the edges. I will select all the edges. Control B. Control B will give you a bevel. Now, you see you've added 2 more segments over here. So, and I can reduce the fraction of it, say by, 0.3 sounds good. Yes, looking fine. So now when I press 3, it will still retain its shape. So it is now a smoother model, but it has still retained its shape. Going back to the first one, pressing 1. Going to mesh tools, insert edge loops. Now I'm going to make a loop over here. Same as here. So I've created these 4 loops. Now let's see what we can do with these. Now I'm going to rotate it downwards. pressing Alt middle button and drag. And I can shut off this grid from right over here. Now, if I right click to object mode, I have these components of a polygonal structure. So every polygonal primitive will have these components. The edges we just saw, you can select the edges. Vertices are as they are. The faces will be the space between that is encapsulated by the edges and the vertices. And the UV. Now the UV, these are helpful during the texturing part. So we will get back to these. And vertex faces. Now this is important to see if you have some extra faces that are not required. That will help you identify whether your model is going correctly or not. So we go to faces, and I will take these faces. So these are the bottom faces, except for the center face, I have taken all the other ones. So all the outlining faces I have selected, and I do Control E. Control E is for extruding. Now let's see, if I extrude something, it gives me extra shape. So from the same polygon, I have extruded something and it made a hollow material inside. Okay, pressing enter, Q. Now I need 4 pillars on the edges. So again, I will go to faces, select these 4 points, Control E, and I'm going to bring them down. So, okay, again, pressing space bar, going to my side view just to make sure the proportions are fine. It's looking fine. Again, going to object mode, and this is my table. So again, these are completely rough and basic designs of the objects that you see in your daily surroundings that you can make within 5 minutes. This is a very simple prop. But however, if you want to make details in it, then that is more difficult. It's not difficult, but it's fun. So you can add more edge loops here and make designs and engrave things on the table. That we will learn that eventually. But since you're just starting out, work with the basic block-in and the shapes. So now everything else that I have created will have the same, it will retain its structure basically, because I've given this bevel. Now, same way, let's try another cube, and we will make a chair to go with this table. Pressing R for scaling. W is our move tool. Okay. Now, first we need to decide how many loops we need in this. So what we need here will be 1 backrest and 4 legs. So for the same, we'll decide the loops accordingly. So we go to the edges, here mesh tools, insert edge loop. So this will be for the backrest and the others for the legs. Now, okay, let's select these three faces for the backrest. Again, Control E for extrusion. First, we move it slightly. Again, pressing E for rotation and then extrude. Again, you can shift to your different viewports to maintain the proportions, because that again is very important. Okay, pressing Q. Q is the select tool. So now pressing F. So these four for the legs. Control E. Actually, here we can do Control E, and then let's reduce the size. And then we pull it out. So this can be your basic, say, study table or dinner table, whatever you want it to be. Okay, so this is something that we've made with the cubes. Now let's try something with the cylinder. Now I'm going to turn my grid on again from here. Now for a cylinder, you don't actually need 20 subdivisions. You can still do with say 15 or even 10, but we'll keep, okay. Again, pressing R. And now I need to scale it from both of these axes, the X axis and the Z axis, with the same proportions. So I'm going to go here, this little green button, and I'm going to stretch it. Again, pressing W. Now, same thing if I want, then I can just duplicate it by pressing Control D. So by Control D, I have duplicated the same object at the same place. So I can just select the second cylinder and I can move it up. So again, I press spacebar and shift my viewports. Like so. And if I want to, I can scale this down to make it look like a step. So this is my base. So if we're creating, say, something of an architectural kind of a thing, maybe just something you see in a garden. So let's try that. So I'm making the pillars. And there's this button, it's called wireframe on shaded, which means it will show me exactly where the edges are. So I will have to turn it on in every viewport, the wireframe on shaded. Okay. So now I want these pillars to be all around and at the same axis. Matlab, if I just say, if I duplicate it by pressing shift and dragging, so I can do this, shift, drag, but ये फिर आगे पीछे भी हो सकता है. There's no guarantee कि it's going to be on the same point on this place. So what we can do is, we can simply, this is called a pivot point. We can simply move the pivot point. So we're going to press D, and you see this, the cursor has changed now. So when we press D, we're simply going to move the pivot point to the center. So the pivot point has been moved to the center. So now, if I were to rotate my object, it won't rotate normally. It will rotate around the same points. It will orbit around the center. Okay, so now there is something known as duplicate special. I have already changed the pivot point. I go here. Duplicate special is Control, Shift, and D. So let's see what this is about. So here, what we can do is simply, we can find out the number of copies that we need and rotate it to a certain number of degrees. And we can just generate copies of the same thing. So say it's a 360-degree thing. So 36, and I'll make 10 copies. So if I apply it, see, automatically my work is done. I don't have to manually shift everything and make sure it's in the right path. Now, again, for these pillars, I don't necessarily need the same, let me Control Z. Here, I don't necessarily need 20 subdivisions. I can do with just 5. Maybe I want to make it more stylized. So six. Okay. So 6 with the pivot point at the center. And again, going to duplicate special, 36, making 10 copies and applying. Easy as that. Now what we're going to do is, we're going to take this second cylinder that we had, and we're going to copy it upwards. So I can either do Control D for duplicate, and then I can move it up, or I can simply clone it. So that means pressing Shift, you can see the clone that is here. Okay, let me go closer. Selecting the second cylinder, Shift, clone, and moving it upwards. Now I've introduced a sphere to this plane. Pressing R, and I like the size of this, so I'm going to just move it upwards. And I just want half of it. I don't want the full sphere. I want a hemisphere. So I'm going to right click, go to face, going to the side view, and I'm going to delete half the faces that I don't want. Selecting all these faces and simply delete it. So now when I go back to object mode, I can simply bring it down to about here. And roughly my space is steady. Now you can press 3 and this would be how it would look. Now the problem here is that we have not given any supporting edge loops. So this is what I wanted to tell you. Here, if we had given it a bevel or some supporting edge loops, then the edges wouldn't be this sharp. So always remember when you're working, make sure to bevel everything that you do, all the edges that are necessary. So let's try it right now. I'm going to select these edges. Again, wireframe on shaded. I'm going to edges. Selecting all these edges and Control B. So this will give me a smoothness, and making segments to 2 and fractions to 0.3. And for these, I don't necessarily need to bevel the pillars. I can simply just insert edge loops. Oh, that's okay. See, now if I only want to work on the pillars, so I can isolate them from this button right here. Going to edges and selecting the lower edge and the upper edge and giving it a bevel. See. So maybe we can duplicate special this again. Isolating this. Edges. Selecting both the edges. Control B. So reducing the fraction size to 0.1 because this is not going to be visible. So I'm going to select these edges also. Control B for bevel and 0.2 or 0.3. Going to object mode. Again, here we can go to wireframe mode because we need to see where the pillars are landing. So Again, the pivot point is in the center. We go to edit, duplicate special, 36 degrees, add 10 copies, and apply. Now let's see how it would look at when we press 3. Yes, looking more sturdy. So you see, you can just use the basic primitives to create anything. You can create different designs with these primitives. Now, let's talk about different materials. So now I have 5 spheres. So we're just going to see the different kind of materials that Maya provides, and we're going to use those. So the default material will always be Lambert. So you don't change the Lambert 1 settings ever, because anything that you use after that, the settings will still remain. So you will have to go to the Windows preferences and settings and preferences to the plugin manager and then reset those settings. So try not to change the Lambert 1 settings. So we're going to right click. We're going to assign favorite material or a new material. So favorite material will provide you with a list of the basic materials that Maya has. So we're just going to go for Lambert. And right here in this attribute editor, you can see that Lambert 2 has been applied. And Lambert 2 will allow me to change its name also. Which is why it's always more better and recommended to work with Lambert 2. So here for this setup, I'm also going to introduce lights. Now, major part of lighting we will cover tomorrow, but for now, use these spotlights. So pressing E. And cloning it for the other side. Okay. And introducing 1 point light. So this is what our scene will look after lighting. So for now, I have just added a second Lambert. Now, Lambert allows me a lot of different attributes. For example, the color. So now I can change the color to, say, if I want a orange. Now notice that all the materials are basically going to teach you about how they calculate the specularity and the reflectivity. So specularity is the shine and reflectivity is how it reflects the surface. How the light will reflect and bounce off of the object's surface and how it will affect the actual environment. See, so now if I increase the transparency, it will act like a transparent object. So it will allow light to pass through it. The ambient color will make it look like it has a glow, but it's not going to be a light source. Now, a glowing object and an object that is a light source are two different things. So this will just make it appear brighter, and incandescence will make it look like a white light. So again, this is also does not make the object into a light. It just makes it appear like it is. So like it's the moon's surface reflecting the sun's light. So it appears to be glowing, but it's not actually a source of light. Then let's move on to the next main material. That will be blin. Now notice you see these three spots. So this is how the light will affect a blin surface. Again, let's see the attributes. So we'll make it yellow. And again, the transparency, ambient color, and incandescence will work the same way. However, what's different is this specular shading bar. So here you can see the eccentricity. That is how the light will affect the surface of the blin object. So you can see the highlights and the specular roll-off. So that means the softness of the highlights. So here the eccentricity is about how much area it will be affecting, and the specular roll-off will decide how well the highlights will be blended. So you can see this fall off from white to yellow. So that is what this will decide. And also it has a reflectivity column. So increasing the reflectivity would mean that not only does this have a highlight from the light, it will also reflect things from its surroundings. Like if I have a whole scene of a room and this is suppose a football. So if I increase the reflectivity, it will show me things that are in the room, but they will be reflected on the surface of the football. So the reflected color, the reflected, here you can add your HDRIs as well. So again, we will come back to HDRIs tomorrow. So that's part of lighting. We will talk about that in a minute. Okay. I'm going to leave it at the default settings. Then moving on. Assigning Fong. So now there is Fong and there is Fong E. We're going to see both of those materials, starting with Fong. So you can see, you can see the difference between blin and Fong. So you see the light is affecting this in a much more opaque and rough way than this. This has a much more shinier surface than blin. So blin is shinier than Lambert. Lambert is the most basic of the materials that you can find. And Fong will be shinier than blin. So let's see what Fong has. So these, again, the same values, transparency, ambient color, incandescence. Now let's talk about diffuse. So diffuse is again how well that the color and the other attributes will diffuse with the surface of the Fong material. And again, translucence, we talked about this. And here you have translucent depth as well. So you'll get the same effect as the intensity and the exposure. Here with specular shading, you have something called as a cosine power. So again, this will take the size of the highlights. How much area will the highlight be affecting? So again, these are, you see the highlights, they're in shape of certain spots. So these are just spots. And again, the reflectivity and specular color, all of that can be toggled with, as it was in this case of blin. Moving on to the next shader. So here we have form E. Now let's see the difference between these two. So here you can just see that the surface is much more metallic than form. So even the translucence and with the diffuse, even though they are the same color, they are appearing to be different because of the metallicness. Now let's see the roughness here. So this will allow you to make it more glossy. More than metallic, it is more about the glossiness. And since the material is already quite glossy, so even the slightest change in the highlight size will give you very different results. So here you don't have the fall off that we had in blend because it's not required, honestly. The surface is already so shiny and glossy that the fall off is automatically there. And the whiteness can be reduced, but again, that is all part of the highlight. Let's try to change the specular color here. So you can see as I go to darker tones, you can't see that specular anymore because you will notice every time you have a highlight or a specular, it needs to be a lighter tone for, well, obvious reasons. It's a light, so it needs to be reflecting like that. So if my, say, atmosphere has a, suppose, a pinkish sky, and that is a light that is falling on my object, then I can give it a extra pinkish specular, which will make my object look much more realistic. Now moving on to, now this is a slightly different kind of material that we haven't seen before. Now, when you see assign new materials, again, you're going to see a lot of materials. You don't necessarily need all of them. So we're just going to go through these 5. This anisotropic. Now, here, if you notice, the specular is completely different than all the other ones because it's in a direction. Now, let's give it a, okay. Say we give it this kind of a color. So there are 3 lights in the scene, and for each light, it is giving a different specular in the same direction. Now, while you have these same attributes, here you can see you have a different angle for this. So you can change the angle of the specular as well. That is depending on your texture. And you can decide here the fall off, and everything will be decided by the spread. And make it glossy. And Fresnel index. Again, Fresnel index will help you decide the highlight, the values of the highlight. So again, let's change the specular color into, say, something more visible. Okay. Something like this. So for this, in this environment, these highlights are not making sense because your highlights always need to match with the direction of the light. So I'm going to go back to this angle that we had before. This makes sense to me. And And maybe I'll reduce the roughness. So these are how different materials will be affecting your scenes. Now, the ones that we will be using mostly will be Arnold. Now, AI standard will give you a lot more, well, not more, but different kind of attributes. Let's see that as well. Okay, right click, assign new. See here, you won't find the AI standard shade over here. So we go to assign new material because it's a Arnold input. So Arnold is actually a separate renderer, but they have a inbuilt partnership with Maya. So when you download the software, you will see that Arnold and Bifrost and Mash, these three are already there, and even Xgen. So these are all separate softwares that have eventually been included in Maya because these are the ones that are mainly used. Now, people also use V-Ray for lighting, and V-Ray also has amazing shaders, but then again, it depends on the use, like what usage is required. So here we have AI standard surface. Let's give it. So we'll give it a lavenderish color. And now you can see these shadows over here. So these are a lot more defined when it comes to Arnold, because Arnold is again a lighting renderer. So all of these things Arnold will do better. So I have first, just for base color, I have these four different kinds of, what do I say? Not attributes, but these four different components. So when I take a render of this, let's see. So you see, again, the light is not enough for this, but if I were to increase the intensity, okay, so I've increased the intensity of some of these lights, and I'm going to see the render again. Now, as you can see, the weight defines the weight of the color, and the roughness and the metalness is also on the surface. So all of these attributes will not be there in the Maya provided materials. That is Blinn and all of that. Those are the ones that are already there, but they won't let you toggle these values. So again, you can change the weight of the specular and the, as well as the color and the roughness. So you see, if you increase the roughness, it becomes like an absolute plastic eraser, maybe. So reducing the roughness will give me more of a glow. Okay. So, so far, do we have any questions? Can I move on? Okay. So now we're going to go to the UV editing. So the things that we saw here we saw something known as UV. So now UV is basically the same coordinates that are in the 3D system that can be seen in 2D. Now here there are X, Y, and Z coordinates. All of these coordinates can be unwrapped for a cube to look like this. And here we can place the textures. So this is the main part of texturing, especially if you're doing external textures. Now, bigger companies go for different softwares other than Maya, like Substance Painter for texturing purposes. But Maya is also a very good software. It has everything. Just like Blender. Blender is easier to learn, but Maya is the professional software. So any object that you have, anything that you create, that can be unwrapped in the UVs. Now let's see how that works for different primitives. And this, by the way, is a workspace. So you have many different kinds of workspace in Maya. So originally you'll be working in something called Maya Classic. And do I have, let me take a new scene. Okay, so let's start with the plane. Moving on to the UV editing workspace. Is this fine? Am I going too fast?
No, ma'am, you're not fast. It's perfect.
Okay. So originally you have a certain number of UVs over here. So like I said, UVs is about the same coordinates that are in the 3D setting, the same unwrapped to form a 2D plane. So for a plane, you already have this kind of a UV shell, which is perfectly fine. So usually we don't touch the planes. However, for a cube, this is not necessarily the best way to have the cube, which is why we're going to see how this works. Now, there are three kinds of UV settings. You can have cylindrical unwrapping, planar, and spherical. And the one is automatic. Now, automatic will not always give you the best results, which is why I would suggest you do it manually using these three. So let's start with planar. Now, again, I know this looks a little bit rough, but it's not. It's very simple. So first we're going to start with, first actually, let's start by creating faces. Now, on your right, again, you will see a lot of different kinds of tools that are available for you. So the main ones that we will need are cut, sew, and unfold. Everything else that will come later. So first let's select the edges, and I'm going to separate all the faces. So I'm just going to cut it, and you can see that these are white boxes now, which means each of them is a separate UV shell. Now, say if my box was, again, going to object mode and moving it. Like so. So all of these UVs that are stretched, these will appear in my textures. Suppose this has a wooden texture, then that texture would be stretched in these parts, which is not acceptable, which is why we're going to go to a planar. Now that we have all different shells, we go to our planar. Now my x-axis means this and this face. So I'm going to go select the UV shells over here and shift over here. And then make sure to keep the keep image height with ratio on, because otherwise it's going to look weird. See, so it's not going to give you the perfect UVs. You need the perfect squares as you have over here. So we keep this ratio on and it will give you something like this. So we'll just select it and move it upwards. Here you see you have two UV shells, which are the same. However, this one is red because this is inverted. Now this is in the positive x-axis and this is in the negative x-axis. Again, thoda sa maths hai, but that's fine. So we're going to go to the red UV shell. We're going to open our transform toolkit. And here you have something known as flip over here. So we just flip it and it's perfectly done. Same way, we're going to go here and here. And this is my y-axis. So I simply move this out of the grid. I'm selecting the red one and flipping it. Now I need to select these edges and make sure that they are all forming one UV shell instead of 6. So I'm just going to select edges from this one rectangle and I'm going to go for stitch together. Now what stitch together does, it allows me to stitch all of the edges across the whole rectangle. So now regardless of where they are placed, the computer will just do that for me, the software. So again, I'm going to select this one edge. And when I select this edge, you'll see that the other edge is automatically selected. So I just need to do this. And this is what my UV shell should look like. So again, in the UV editor, the same Q, W, E, R, the same shortkeys will work. So if I want to scale it down, I'm just going to press R and I'm going to bring it down. Moving on to the sphere. Now, see, the sphere has something like this. This is the inbuilt setting of the default UVs that are there. So all these triangles, they are just going to slow us down. So during the rendering process, it's best to avoid having these triangles. So we're going to go to the UV shell and selecting Q. And here again, you have the same tools over here. This is for spherical mapping. So I'm just going to select that. And this will give me certain options in the viewport. So this red button, I'm going to select it and I'm going to close it over here. And same with this blue button, this green one, I'm going to take it upwards. So now you can see my UVs are slightly stretched at the center. So here at the equator, everything is slightly bloated and it's slightly constricted at the edges. So what we need to do is we go to the edges, say this one here and this one here. We create a cut. And now we have 3 UV shells. So we're just going to move this out. And this UV shell right here. We're going to select the UVs. So when you right click over in the UV editor, you have the same components, edge, vertex, and face, except now you also have UV and UV shell. So UV, as I mentioned, are the same coordinates as the vertices. So these are not the vertices to say, these are the same coordinates as the vertices would be, but in a 2D setting. So here, I'm just going to unfold it. So which makes my the checker boxes, it makes them very much simpler. Again, I'm going to select all of these UVs, unfold them. So this gives me a circle. Unfolding, and here I need to select these edges and I need to stitch them together. So this will give me a simple plane. And same way for the lower part. Now what is important is that these are three shells of the same object. So for one object, you need to have similar proportions. Now, as you can see, this and this, they are not of the same proportions. So to manage the proportions, what we need to do is, we just select one of these. We say texture density get. So this means, oh, that's a really high texture density. So what we're going to do is, we're just going to bring it down to 50. We're going to select all of these and we're going to set them. So now all three of them are in proportion with each other. So all I need to do is make sure that they are together by selecting just one part of the edge and stitching it together. So this will be my final UV. This will be my UV shell for the sphere. Now coming to the cylinder. Now the cylinder is already going to give me something like this. So I already have the top and bottom shells that are perfectly laid out for me. So I don't need to change that. However, this center part, this is quite stretched, as you can see. So this right here is a button for cylindrical mapping. I'm going to click that. And this, again, cylindrical mapping and spherical mapping will give you sort of a shell that you need to close. So completely closing that. And again, I can still see that the checker boxes are now rectangular. So I need to change the height. So that I can either do it from here, or I can bring it down over here in the UV editor itself. Let's see that. So I'm in the UV editor and I'm pressing R. And just making sure that the checker boxes are the same size. That's it. And now I can bring it up and you can see that everything is in proportion. So we just make sure all these three shells are in proportion and then we join them. So these are how you can create UV sets for different primitives. Now these are just the primitives. However, when you create anything, a character, a prop, a table, a chair, all of those things will also need to have certain UVs. So this is how you can assemble those UVs. You can break it down into different primitives and then you can make the UVs. So far, so good. Okay. Now coming on to the project. So what we really need is a simple animation. So you can create anything from what we have done today and one more exercise that we're going to do right now. And that will be marked for tomorrow. And that will have 3 prizes, as ma'am has mentioned previously. Let's just see about the animation part of it. So with what you know now, you can easily create anything. You can do the modeling part, but the animation of it, let's see how that works. So again, pressing Q, we're in the object mode. Going to right click, assign new material, and Lambert. Like I said, we don't work in Lambert 1, we work in Lambert 2. So say I'm just going to give it a just any color, it does not matter. Okay, and then we take a sphere. This can be a Lambert 3. Okay. So this is a basic scene that I have right now. Here we have a simple plane and a sphere. What we're going to do today is ball bounce. Now this is the most basic exercise that you will do anytime you start animating. And it's actually the most important one as well, because if you know this, you know most of what animators do. So again, animation is mostly about translation, rotation, and scaling. So let's just see how that works. Say I'm at a height of 7. So now, if I just want to simply see how what a ball bounce looks like, so I just know how it works, right? In the real world, if you play cricket or football or any sport, so you just know when it bounces, it comes back up and it comes down with this higher velocity, right? So we're going to use the same principles, but here we will have, again, we can go to a different workspace that is for animation and it's given by Maya right over here, or we can make our own settings. So let's just see how that would go. So at the animation editor, Windows animation editor, there's something called as a graph editor. This graph editor will show you the same form of animation that you give in terms of translation, rotation, and scaling, but in the form of a graph. So first, let's see something. How to set a key. Now this right here is my timeline, the bottom. So now I have 200 frames. We know that 1 second is made of 24 frames. So say I have 240 frames. So that means that's a 10-second long thing. Now let's see. I'm at frame 1. So right now at frame 1, if I just want to see my translations, that is the movement, which is by W. If I move, my move tool is at W, correct? So here I press S, I select the sphere and I press S. So that will give me my first key. So this is my main keyframe. This is where the animation will begin. So now going to my side view. And say at 15, I want to bring it down to 1. And pressing S again, so my second keyframe. Then at 30, we go back to 7, pressing S. Oh, wait. So when you press S, you're basically locking all the translations that you have made. So Right now, we're only working on the y translate value. Y. Okay, so here when I press play, you can see this is how my animation is looking at the moment. Okay. Now you can see that this is not looking very realistic because the bounce is not there. When any object hits the ground, it comes back with a force. It repels with a force, and that force is not there. Right now, this is looking very hydraulic. So all of that we can change using the graph editor. See, you can see the curve, it's way too smooth. So let's see the translate y. So here you can see that we have way too many options. Now, again, it's very simple. It's this is called break tangents. Here at any point, you can break the tangent into two, and then you can move it accordingly. Right now, if you move it, then it will still maintain the same balance. But if I break these tangents, then it won't do that. Now, let's see all of these. So this is called linear tangent. So linear tangent will give me the bounce that I'm looking for. See, now suddenly you can see that the ball has some weight. So again, this point also should have a linear tangent. But still, this is quite smooth. It needs to have more of a bounce. So even though this is linear, both the tangents are still logged. So if I move one side, the other will be affected. So let's break these tangents. And then when I move one side, the other is no longer affected. So the idea is to create an actual bounce in the graph. So again, going to break these tangents and making sure both sides are smooth. So again, if something like this happens, then you know that your graph is wrong. So you need to make sure you have a smooth tangent. And for that, you can move the key points here as well. So something like this is looking smooth. Right. So you see the difference between the first ones and this. Now let's make it move a little. So we'll translate the same in Z axis. Now here we already have some keyframes, but we don't need those keyframes because they're not of any use. So we're going to leave the first one and delete the rest. And we're shifting from this viewport to this. So again, as you can see right now, the ball is bouncing on the same place. What we need is, oops, sorry. Right. So, so this is the current situation, and we're going to move that. Right. So right now, this is in X, translate X, this is at 9. So we're going to move it in translate X as well. So we go to translate X. We delete all of these. And at this frame right here, on the 120th frame, we're going to take this and make it -9. And we press S. So you can see that automatically there has become some changes. So when I select the sphere again, I can see that my X translation is like this. So here I'm going to breakpoint and make it like this. So, but this part I'm going to leave it like this. Because what this does basically is that it slows down the exit. So when the ball is finally going to drop, it's going to roll over. We can move this a little bit. Fine, looking fine. So now you can see here in between there are some frames that have been created and that have happened in the graph editor itself. So we don't really need to worry about those. Those are fine. Now let's see the scaling. So if you've seen any animated movie ever, uh, when you throw a ball in a Looney Tunes character in a 2D animation or a 3D animation, you will notice that there is something known as a stretch and a squash. So right before the ball hits the ground, there is a certain stretch. So that is what we need to work on to make this more realistic. So say around the 13th frame. Now we're not going to worry about the rotation at the moment, because again, that is something a little advanced and you need to practice this before you get there. So let's see, we're going to press R. So R is for scaling, and we're going to rotate this slightly and then stretch it. So again, going to my side view. Okay, this is looking fine to me. And pressing S. So when this ball falls at 15, here it needs to be a little squashed. So again, I'm going to press R and I'm going to squash it a little. And hitting that S button again. And at 17, again, we're going to slightly rotate it and stretch it back. So you see, when the ball is in the air, it's a perfect circle. But as it comes down, it needs to stretch, squash, and stretch back again. Same thing we need to do around every keyframe that we have created so far. So every time the ball hits the ground at 45, say, so at the 43rd keyframe, we're going to simply rotate it a little, press R and squash, stretch it. And then press S to hit the key. And at 45, we are going to squash it. Again, press S. At 47, we rotate it back. So again, here we have some space where we can actually allow the ball to roll over. Let's see what it looks like right now. Pressing F for full screen. All right, let's play it. So you can see it looks like it does not look as solid as it used to, but this depends on the kind of animation that you're working with. So this is something that I expect from you people as well. We've actually finished earlier than I expected. So for your project, I would like you to create anything that you like. It can be a simple table chair thing and the chair being pushed in. A simple animation is all I'm expecting. You don't have to do anything drastic or big. But let's see how that works out. If you can pull off a ball bounce, that would be amazing because I'd like to see different variations of it. So that's all for today.
Okay, ma'am. So thank you for enlightening us with your knowledge, and it will be very benefit for us for tomorrow's competition. So I request Hardik to take over the question answer session, if any.
Yes, please.
Thank you, ma'am, for the wonderful session. It was really helpful, and we this was something new that we got to learn today. I don't think that like after attending a lecture that anyone has any queries as of now. Thank you so much once again.
Thank you. So I'll see you guys tomorrow. I'm looking forward to your entries.
Yes, ma'am. I'll post. Kalp, could you please post the feedback form in the chat box? And I would call upon Juhi to present the formal vote of thanks.
A graceful and warm afternoon to our most valued guests, worthy teachers, management committee, and all my dear friends. Today, we all had a great opportunity to know about Autodesk Maya. It is my privilege to have been asked to propose a vote of thanks on this occasion. I would like to thank our distinguished speaker, Ananta Sharma, ma'am, for making an excellent presentation and making this workshop a very meaningful and interesting one. I would like to thank the Vice Chancellor of HSNC University and Principal of KC College, Dr. Himlata Bagla ma'am. Secondly, I would like to thank the Vice Principals, Shri Samarjeet Padhi sir, Dr. Shalini Sinha ma'am, Justin sir, Dr. Tejashri Shanpak ma'am, and lastly but most importantly, coordinator of data science and business analytics, Professor Shailaja Rani ma'am. I am happy to express a vote of thanks to our staff and has made this workshop a grand success through their motivation and dedication. The registrars of HSNC University and teachers at KC College who have helped all of us in conducting and hosting this workshop. No program can be successful without a technical support. So I especially thank the people who have been the backbone of today's event with their technical support. A huge thank you to the members of Data Science and Business Analytics Club who worked hard for the success of today's event. Finally, I thank the wonderful students who have turned up for today's event from not only our department, from the institution too. Thank you so much for your cooperation. Today's event couldn't have been a successful one without all of your support. Once again, I thank I thank you for your cordial cooperation and attention. Thank you.